My name is Stephen Batiche. I've been at Microsoft for 23 years. I'm a technical fellow on the Windows and Devices organization, and I run a team called the Applied Sciences Group. And we work across a whole bunch of different areas, spanning hardware, signal processing, AI, and even developing new experiences through software. One of the big things we're really focused on recently is obviously AI and the silicon that it requires.
Well, it's an honor to meet you, Stephen. Do you mind if I ask you a few
Thanks, Hayden.
questions?
Go for it, man. It's good. Yeah.
Yeah. So at Build, we saw some example uses of NPU devices, like facial recognition and language processing. Can you talk a little bit about what an NPU is and what other uses there may be for an NPU?
That's a fantastic question. Uh, so, uh, uh, a neural processing unit, that's what we call an NPU, is the third processor. It's an emerging processor. It's been kind of emerging, I would say, from the past 10 years. CPUs are really great at multiplying or doing math on two numbers. GPUs are really great on doing math on arrays, and and NPUs are really great at doing math on tensors, which is essentially think about it as arrays of arrays, multi-dimensional arrays, and that is essentially its capability there. It's not to say that you can't do AI on CPUs. You of course can. In fact, like you have accelerators in CPUs that can do great AI, and the same with GPUs. GPUs even have tensor accelerators themselves, but the entire architecture behind it, even how data flows inside to that system, is extremely important and is really a function of what the operation it's going to do and how it's going to do it.
And what other uses, in addition to the examples we saw at Build, do you see for NPUs coming in the near future?
Oh, yeah. I mean, like AI and using NPUs will probably be in every. If you haven't started yet, I don't know if you saw my build talk, but like it was kind of like a big call to action for folks. Like this is exciting. Like it's kind of like, again, like going back to the analogy, like when GPUs came on board. And now everyone uses a GPU, and GPUs are really important. In the web, you want to accelerate graphics, and writing a game, in productivity applications. That NPUs are going to be no different. It's going to essentially have a thread. Every application, every experience is going to have a thread of some level of AI, where we take the kind of the classical algorithm that we used to have, and they'll be machine learned models, machine or AI based models, and so it'll be across everything. Now, what are the things that we're seeing today that helps people give that tangible value? Obviously, anything that has to do with audio and video, AI does a great job at. I can make people. We can enhance video in real time. We can make voices be more clear. Um, Anything where I'm translating like words to another language, one language to another. AI does a really great job at automatically translating things. Anytime where I'm trying to do like text prediction. So you can see that in Office today, where all of a sudden, I don't know if people noticed, but like in the recent versions of Office, uh, like it's predicting way more in front of what I'm trying to type than before. And that's because we switched from kind of classical text prediction techniques to these bigger models that can predict and almost complete a sentence for you. It's insane. This is so magical. Like you're typing, like the demos I see are just like, I can type a paragraph, like you know 40% faster because I can just say, yeah, that's what I was going to say. That's what I was going to say. Keep going, keep going, keep going. And even like doing document auto summarization, you see AI, being able to recognize objects and people on a screen. My team just shipped a this camera. So AI, like this is basically has the neural processor in it. This is the smart camera, the Surface Hub 2 smart camera, and it has an AI processor in it, and it does people detection, and auto framing. Uh, Embedded in the camera runs the application like another application of essentially AI. I mean, AI will essentially be infused in every aspect of what we do in the day, and it's not a scary thing. It's just a very simple thing. It's just take old algorithms that are okay, and you replace them with these newer algorithms that are more powerful.
That's great. So I have noticed that prediction in the latest insider build of Office. It's incredibly powerful. But you mentioned something
There you go.
I wanted to ask you about, which was how close are we to Star Trek's Universal Translator?
Yeah. It's the strides that Microsoft has made, and even the industry has made, in developing these really large natural language models that that you know that are trained essentially on the web, on data, because that's a tremendous amount of data. We now have models that that are one unified model for all languages, and you can put one language in and another language comes out. It's amazing, and you don't have to change models. It's not like you have to know and switch models. Like, it's basically a universal language model. So that reality is kind of here today. Now the universal the Star Trek translator does something else. Is first, it does it in real time, right, while you're speaking, and almost like as if somebody flipped a switch and now all of a sudden I'm speaking Klingon or whatever. And we're not there yet, and there's some physics there that we have to overcome. But the other thing that it does, that vision does, is that it'll learn a new model, right? A new language. Sorry, a new language. Like, I've never heard this language before, but I'm gonna understand it. Give me a few letters, or give me a few words, or a sentence, and then all of a sudden it figures it out, right? Like, we've seen that episode in Star Trek. We're not there yet, but it's not that far off either. Of course, we don't have new
So,
languages popping up left and right either. We can just train on the languages we have.
right. Will developers be able to integrate NPU based AI into existing apps? And if so, what is that going to look like?
Yeah, absolutely. So that's a core piece of work that we're doing in Windows. First, the NPU will appear in the task manager like the GPU and the CPU do, and you'll be able to look at it. We have a unified runtime framework called Onyx, and Onyx ORT, and and on top of that, the layers of WinML. And so developers can even choose using the WinML APIs or of the Onyx APIs themselves to target to run essentially workloads. And you can specify which execution provider you want to use, the CPU, the GPU, or the NPU, to do that. Or eventually, like, we'll just let Onyx figure it out, and it'll just do its best job. Now, in order to utilize each of these execution providers, you have to take a trained model and compile it, essentially, and compile it to the specific silicon that you want to run it on. And that's kind of obvious. I mean, I think people are kind of understand that concept, because today the neural processing, the diversity in the ecosystem is quite large, right? So Apple has one, Android has several. Windows has a few with Intel and ARM and AMD. There's a whole bunch of different ones in the cloud, for example. And what we're doing, actually, and I said this a little bit in my build talk, is we recognize that's a lot of different things for a developer to keep track of. So let's solve that problem for them. Let's develop a solution, and we call it essentially a prototype. We call that a prototype toolkit running in Azure ML. But let's develop a solution that takes a trained model and allows you to compile, and it'll do all that stuff for you. All, like, I want to compile for these are different platforms and these different operating systems, and the dependencies and the compilation steps are all taken care of, essentially. And you just take those, essentially, those binaries, and drop them in your application, and you're ready to go. Use the API, use those standard APIs, no matter what operating system you're on, and then you're off. So absolutely, so, yeah, pretty excited for people to get their hands on. Now the other part I think we have to recognize is that developing your own model is difficult. It's a lot of work. It requires a lot of data. It's a lot of time. It's a lot of training. And one of the things that we're especially doing in Windows is we're going to have built-in models ready to go for developers to use. It's already there. It's already there. It already is optimized. It already runs on NPU, and we're going to let you just use it and give APIs to it. For the example, that face tracker that I used, that I showed in my build talk. Well, be able to essentially, take that face tracker or the segmentation model and use it in your application. You don't have to do your own. And I see most developers doing that, really then trying to create their own model and then figuring out how to run
Gotcha.
it.
That's fascinating. So, kind of stepping back from the NPU and the model level, there's going to be a lot of developers that build, and one of the things I noticed in your background is you're focused on kind of reducing the friction of computing and making it more accessible. What are some things developers who are sometimes deep in code and frameworks, what can they be thinking about in terms of making their applications easier to use and more accessible today?
It's a great question. I did an after-hours session with Scott Hanselman, and it was a fun one. We went into the accessibility lab, and we showed stuff. But the conversation we had along the way, to me, I think, is indicative of potentially one of the greatest changes that AI will offer to us, to the developer. It'll change how people interact with potentially how they need to interact with their software, with the computer. Today, and now let me try to give an analogy. Like today, everything is very explicit with a computer. It's like, you have to punctuate everything. You have to click on the right button, the right pixel. You have to move windows just so. You have to, etc. And that is a very kind of explicit command and control environment we have, and that's because computers aren't that smart. The human has to be so specific about what they want, and if it's one pixel off, it's not what they want. And with AI, you can essentially add a layer of implicitness, of fuzziness, of logic, of high level, like human understanding, or almost or near human understanding of what your intent is, and then help the customer essentially complete that. And I would say like the interfaces there would be much more multimodal. It'll be voice, vision, keyboard, sometimes gesture. You will be able to interact with your computer in a much more natural way to get what you want. Simple example would be like, okay, I have a bulleted list of things that I want to write a paragraph on. So here are my ideas. And sometimes with accessibility, one of the important things you want to do is reduce repeated tasks or things that require a lot of physical interaction. Well, with AI, like, okay, I can either say a bulleted list or write out, and then ask the computer, can you write the paragraph for me using this bulleted list, which is amazing. And then it does it. And that's actually a real thing. That's a real thing. That's a real scenario. That is real technology. And so I would say, the call to action for developers is don't look at the old way. Look forward and almost think of your computer or your application like headed towards like Data from Star Trek. He's basically an AI computer that you interact with in a very explicit manner, implicit manner, and I think that's how applications are going to essentially evolve in the future.
Wow. Thank you so much for taking the time with me today. I really appreciate it.
Thanks. No problem. Aiden, that was fun. That was a lot of fun talking to you. Thanks.
Yeah, likewise.